All right, everyone. So just get yourself a sheet of paper and you're going to record this on your sheet of paper. All right. And this would be really, like Mr. Pham said, it's going to be on the, he's going to get this one recorded and it's going to be uploaded onto the website. So you can practice some of these questions again and again as much as you wanted to. And so you don't need to write down anything except just write down the answer as we go through this practice test. Okay. So let me go ahead and share the screen with everyone. All right, let me go ahead, animation, slideshow, start from beginning. Okay, there you go. Okay, so that's pretty much it. So that's how the test would be.
Sam, there is a way you can go back to.
Pandemic, hindi na sila, no? Gawa ng mga opisina nagsara,
I think
no?
Mr. Pham will be going over the test with you guys.
Okay.
So you
Yun naman,
can
pandemic din.
record it
Bukas
then.
masyado.
Hey Sam, can you mute the mic, man? I can't talk. We need to mute the mic.
I don't have
Urgent
control.
care,
Mr.
no?
Pham has it.
Yan ka malapit.
We don't upload this thing, right?
No.
Yan sa mga trabaho.
Hey, Mr. Pham, mute the mic.
Echo.
Echo.
Hello, Sam. Hello, Sam.
Yes, Mr. Pham.
Yeah, go ahead and run, display the key.
All right, so let me see. 1 second. Let me see where's the key is at. Okay, we can be looking at that. Okay, so let me see slideshow. We're gonna go slideshow. We're gonna go through one at a time. Okay, so okay, share screen. Oops. Okay, can you see everybody see the answer?
Yeah.
Okay. So if you need me to go over a certain one, just let me know, and so I can try. Hopefully, I can help clarify it.
Go slow.
Well, you see the answers, right? So so like I said, if you have any question of a certain one, just let me know, and hopefully I can go over it. Hopefully I can clarify it for you. If not, Mr. Pham would help clarify the answer, okay? So does anybody have question number 1? About number 2? No question. Number 3? Okay, so no question there. Okay, the next set. Okay, any question number 4? All right, any question on number 5? Number 4 and number 6 are the same, so I'm going to skip number 6. Go to the next page. Okay, any question on number 7? Question on number 8? Any question on number 9? No question. Okay, next page.
A little bit slow, please.
I am going slow. You can go, you can always go watch the video later on.
Thank you.
You're welcome. Okay, any question number 10? Question on number 11? Question on number 12? No question. Okay, next one. Okay, any question on 13? Question on number 14? Any question number 15? Okay, no question. Next one. Okay, any question on 16? How about 17? Number 18? Okay, no question. Next one, next page. And question number
So-
19.
Number 19,
Yes,
it's a C, am I right?
the answer is C, correct.
So the first harmonic is whatever the frequency, given frequency, am I right?
Correct. It would be your reference frequency, which is 100 hertz. At the first harmonic, it would still stay 100 hertz.
What about the second harmonic if it is asked?
The second harmonic, it would be take 2 times your reference frequency, which is 2 times 100 hertz, would be 200 hertz.
And like that, third harmonic multiply by 3.
Yes, and 3, 4, 5, as you continue on. Yes,
Okay, thank you.
you're welcome. Okay, question number 20. Question number 21. Okay, no question. Next page.
Sam, can you
Yes.
call it 21?
Okay, 21, when inductor are connected in parallel. Okay, when the connector is connected in parallel, it's similar to what you have resistor in parallel, right?
And it's,
And yeah, when you put in parallel, inductor in parallel, so therefore it's going to reduce the
oh,
inductance.
yeah, I got it confused with capacitor. Okay,
Yes.
thank you.
You're welcome. Okay, next step. Okay, any question 22? Question on 23? Any question on 24? Okay, no question. Next set. Okay, any question 25? 26? 27? Okay, no question. Next. Okay, any question 28? 29.
Yeah, how you got in 29? A.
Okay, so 29, what is the power factor of the circuit with the applied voltage of 15 volt RMS and the current flows of 0.5 RMS and the resistance of 10 ohms? So this one, the power factors is going to be, let me see if I can do insert, let me see, doing text, text. That, let me go ahead and do format. Let me see shading. Give me a shade here. Okay, so power factor PF PF is equal to real power over apparent power, right? So real power is the current times the resistance. So I times R, okay? And the apparent power is I times, let me see, apparent power is going to be I square
I square R.
times R, yes, thank you. And then the apparent power is going to be just I times the voltage. Okay, so therefore the numerator is just this here. And denominator, oops, let me go back page up. Did I go down too far? Okay, so I went too far. Oh.
Mr.
Okay,
Pham?
so number 29. Okay, so this one is going to be here, and this one is going to be here. So this is going to be quantity I square. So I square is 0.5. This one is going to be square times 10 ohms divided by the I's of 0.5 times 15. So and then you just have to just plug into your calculator. So you got a 0.5 squared times 10 divided by the quantity 0.5 times 15. So that's come to 0.33. Okay, did you get that?
Yes, thank you so much. I appreciate.
You're welcome. Okay.
Mr. Sam? Mr.
Yes, sir.
Sam? I think you can choose A because the power factor couldn't be more than 1. So A is correct.
Yeah, so
Without any
yeah,
calculation.
yeah, if you want to be most of your power factors is always going to be less than 1. Nothing's going to be an ideal condition. We want to be at 1. That's an ideal situation, but nothing ever we can't get a 1-to-1 ratio. Okay.
I
So
see what
the-
he's saying now. So since B is 3 and the other ones are higher than 1, you could just basically look at A. Is
Yeah.
that what you're saying?
So you just eliminate B, C, and D. Those are pretty much, yeah, that's way over the limit. There's no way you can get more power out something. You can only put in as much, and that's the amount that you can get back. Nothing more.
But if in case both the options are less than 1, then we should we should know how to calculate it.
Okay, yeah, and then and then make sure that you know how to do the calculation. Okay. So did everybody catch that or? Okay, so that's number 29. Okay, next one.
Sam, can you explain 30?
Okay, the number 30, the output of simple RC high pass filter appears across the, okay, remember the high pass on the low pass, it's let me see, if you look at the circuit wise, you're going to have like circuit like this one here. So now I'm going to take out the inductor. Okay. Okay, so you have the RC circuit. So we want to do is, so this is represent a low, this is represent a low pass.
Mhm.
Okay, so when you have a high pass, the capacitor come before the resistor. The resistor would be here.
Right.
And so therefore, yeah, your output would be what they said they it's going to be passing out. Let me see if I can make lower this one a bit. Oops. Let's see where my. Okay, so
Across the resistor. Okay.
yeah, it will
Yeah,
be over
okay.
the resistor. Yeah, if you look at the V out, would be right here at this corner, and this resistor goes here and capacitor here.
Okay.
That's what that is for the high pass. Yeah, that is something that you have to remember and can do configuration because you know company will be testing you to understand. Now, if the company working with a lot of filtered system, yeah, this is the circuit that you have to be familiar with, which is coming first, the capacitor or the resistor, and that's how you determine whether it's a low pass or a high pass filter. Okay. All right. Okay, any question number 31? And number 32?
Sam,
Yes, sir.
you said the high pass and the low pass is determined by the placement of the resistors and the capacitor, determine which one is first and which one is last.
Yes, so this is, as you can see, the one that you see my multi-sim, right?
Yes.
So this is multi-sim, this is represent a low pass. Okay, so let me go ahead and sort
The
of.
low pass because the resistor is before the capacitor.
Yeah, so resistor before the resistor before the capacitor, this is represent a low pass. If you got
And vice versa would be a high pass.
yes,
Okay, thank you.
you're welcome. Okay. All right. So any question number 30, 31, or 32? Okay, so next page. Okay, and the question on 33, 34, 35.
Is quality and quality factor same?
Excuse me?
The option, the correct option you wrote is the quality of the circuit.
Yes.
My question is the quality and quality factor are same or different?
Quality factor is a, yeah, when you get into quality factor and then it's a just a little bit, yeah, you can say quality factors and quality, it's pretty much comes into, you do almost a basic calculation. Okay.
No, but what I believe is there should be a word written quality factor.
Yes. Okay.
Because we are talking about electronics. And
Yes.
if it is not, then it makes a difference.
Okay.
This is
Yeah,
just what
but you had to take with Mr. Pham, so this is what he said. That was on his answer. Okay. If you see on the test that comes up, yeah, just think about the quality or quality factor.
That's a different.
Yes.
They're just telling you how good the inductor will be. So now Q equal what? Ri over IL. And that's what they call quality of the circuit. Nothing to do with the factor.
Okay, so both are different terms.
One just telling you how good the inductor will be in the circuitry. The other one, you have to do a calculation for the ratio.
Okay, so
So basically, he's saying one is, has to do with the inductance itself, and the other one is a ratio, which is.
yeah, just make sure that if you want to find out the real, just go ahead and Google the information, the Q of a wire. And let's see, Q quality factor. And so you can read up a little bit more on that. Yeah, mainly like Mr. Pham said, the Q is mainly, so you got quality factor, the Q, coil easily pass direct current, but not as, okay, so just read that and just give you a little bit more. And I think Mr. Tai can give you more clear once it goes into when he, yeah, I think he did on this one, he did a lab on this one earlier that talking about the inductor, the Q of inductor, okay? So you can go watch the video from the website a little bit more. And now I don't remember the date that he did that, but you can always go to watch the video that Mr. Tai presentation. Mr. Tai, so Mr. Tai here. So somewhere around, somewhere here, we're talking about the parallel. So anything about the AC coming up from here. So one of these, I remember he went through that. Okay.
Okay, thank you.
You're welcome. Okay, so next one, next set. Okay, any question 36? Any question 37? Question on 38? Okay, no question. On with the next set. See if I can-
Now we need a help on here.
Yeah, this one just a little bit. Yeah, just a little bit. Take a little bit of time just to work through it. Okay, yeah, like Mr. Pham said, there won't be too many calculation. You maybe have like maybe 10 questions about just doing the basic calculation. But the total amount of the test question is going to be total of 50 questions. So, and most of them, and it's going to be a multiple choice, so it's not going to be too difficult. So you do the calculation, just figure out which one is it, which one is the answer. So anybody have question number 39 or 40? Okay, no question. I'm onward to the next set. I didn't do the calculation for this one, 40, 41. Oh, I did not have time to go over do that calculation. Sorry about that. So then I made the XC here. So you're gonna take the power supply here, square it, and you divide it by the XC, which is 10 ohm. That should give you the 4,000 VAR.
Can you repeat one more time?
Okay, you're going to take the voltage that is over the parallel side. So it's going to be just 200 here. You're going to square it. Okay. 200 square. And then divide it by 10 ohm. That's over the XC2. So that's give you 4,000 VAR. Okay. So it's going to be just so this is reactive power as this one is going to be over. Oops. So this is S over C2 is going to be the voltage square. So it's going to be the 200 volt square divided by 10 ohm. Okay. And that should comes up to the 4,000 VAR.
And then 42.
Excuse me.
And the next one, 42.
42, we're gonna be, that's gonna be taking the, okay, so we're going to take the voltage, same thing, the volt. Okay, so we have the current and the XC, so therefore the SC2, SC1, oops, why is that? So SC1, would you go to same thing? We're going to take the, okay, so this one we got the current. So it's going to be current square, the times XC2, XC. So yeah, so current in this case is 20 amp square times the XC1, 6 ohm. Okay. And that should be just like I said, 20 square times 6. So that's going, oops, that's the, wait a minute. Okay, so XC.
That's not an 8,000.
Yeah, the
Okay.
answer is A.
Yeah, the answer is
Sam, is this the 42 the same question as 40?
That will be XL. Sorry.
Yeah, yeah, I'm sorry. So, okay, so it was supposed to be, he wanted to solve for XL. So this was the question here is incorrect. Okay. So this one was supposed to be SL. So this one should be XL here. So this one's supposed to be L, yes. So therefore, you do the same thing like the one on top here. So you're going to be 200 volt square divided by 5. Go to, so 200 square divided by 5. So that's 800 VAR, okay? So sorry about that, this one, the question here is supposed to be the inductive.
And for the XC1, suppose it is asked for XC1, then the method just you showed earlier before a
Yes.
couple of minutes, the same one.
Yeah,
I
XC1, this one, yeah, this XC1 would be here.
Okay, got it. Thank you.
You're welcome. So that we got the, okay, so XC2 and SL, okay, so everything. So everybody's good?
Yeah.
Okay, next page. Okay, so this one just kind of what we just have a minute ago, just do the calculation. So we're gonna be just taking the, so the 20 times the, so it's gonna be just that from the previous step. So it's gonna be this one here. So it's gonna be just subtract over the current times this one here, the total current. over the parallel. So this is represent the one that's going to be dropping over the parallel right here with the total current, minus just the drop that is over this one here, the XC1. And that should come give you the 1600 VAR. Okay.
Sam, I got a question for you.
Yes.
For that value 2400,
Yes.
okay. I know we did it with I square
Okay.
times the resistance.
Mhm.
Now, could we have done it with voltage square divided by the resistance?
This one right here.
No. Well, basically, we're going back to question 40.
Okay, question number 40. Okay, right here.
Yeah, you see how you got the 20 amp square times 6.
Yes.
Now, could we have done it with voltage square divided by the resistance value?
Times the resistant value, but we don't know what we don't know the voltage drop over the R over the resistant. Oh no, we don't know what the voltage drop over the XC1 is.
Oh, okay. Oh,
So therefore we cannot use the voltage since we only have, they gave you only the current
Okay.
here. Yes.
but we know the voltage across XC2 and XL.
Yes, exactly. It's this one, they give you the voltage, therefore we can use it directly, the voltage formula.
Okay. All right. Thank you.
Okay, you're welcome.
Hey, Sam, just as a note for everybody, the powers, we got the three of them, the three formulas. P is equal to E times I, and P is equal to I squared R. And
Yeah,
then
just
P
go
is
to,
equal to
just
V squared over R.
Just go to the website. Just go, Mr. Pham did put up the website here on the power and AC, right? On
Yeah,
there's a lecture.
Yeah, I was just mentioning it.
You can we'll go watch this video if you want to have more. If you need some extra more information, just go watch this video. Mr. Pham did go over the power on that in this AC circuit.
Correct.
Okay. So any question on number 43 or 43 or 44? Okay, no question. Next set. Okay, any question on 45 or 46? Okay, look like everyone got that one. Very good. Okay. Okay, so this one is just a basic, it was very simple one, so just basic series circuit. Did I skip one earlier? Oh, okay, yeah, so, yeah, so then you're gonna use this current that we solve in 46 to use it in 47. And 47, 48.
When you get finished, Sam, I think somebody had a question on 44. They put it on the chat.
Oh, sorry, yeah, if you speak it up, sorry, I wasn't reading the chat. Too busy with watching that. Okay, please go back to 44. Okay, what's your question on 44?
Somebody wrote it up there. I didn't do it. but
Right, okay, Kim, so, what are your question on 44?
I don't know who wrote it, Sam, but they put it on the chat.
Yeah, I see the name.
Maybe they just wanted to see how it's done or something.
How you get 44, 4 ohms, right? You're going, oh, this one, 2 square, I'm sorry. This one is gonna be 2 square.
44 is a
Okay,
reactive part. Right?
so that's gonna be 20, so that's 1600, the S net over the current square. So that's why you got 1600 VAR divided by 20 amps square. So that's 20 amps square, that should be like 400. So that means 1600 divided by 400. Okay, so the answer comes to 4 at the end. You're welcome. Okay. Sorry about that. I did not finish out writing out all my notation there. I didn't have much time to go through, and so that's why I was rushing through.
Just a second.
Okay.
All right, got it.
All right. Okay, so we got on the 47, 47, 48. Okay, any question on the 47 or 48? Okay, so next one. Last set. Okay, so
Mr. Semi,
yes.
do we turn this in at 12 tomorrow?
Why would you turn it in? We already gave you all the answer.
Oh, sorry, because just a little trying to prep myself for the quiz and getting my
we-
tests all in there.
This
you
is a
know?
review. This is a review section. This is a review session.
Okay,
We already
yeah,
gave
thank
you.
you.
Yeah, we give you all the answers. You don't need to turn it in.
Okay, thank you.
Welcome. Okay, any question on 49 or 50?
Thank you. Bingo.
Okay, bingo. All right. So good luck on your quiz and good luck on your studying, everyone.
I have
So-
two questions.
So when we have a final quiz on Monday?
I don't remember. Mr. Pham did post that on a couple of days ago. So let me see
Yeah.
when was it?
I think so, coming Monday, next Monday.
Let me see when was it? I forgot to write it down. Okay, so this one was it. Okay, so this one here. So yeah, so final test Monday, August 23rd.
I have
Okay.
two questions, Sam.
Yes.
First, the next test on Monday is going to have the same number of questions.
There
Similar.
gonna be 50 question, like we said, like I just mentioned. It's gonna be 50 question. It's either pass or fail, and then that's why we give it on Monday. So if anybody did not do so well, you can do some makeup. You can do a makeup maybe on Tuesday and Wednesday. You can do makeup and resubmit it in. Okay.
Okay, the second question is, in this test, I have problem with the oscilloscope, right? So
Okay.
what do you recommend?
There's a, yeah, there won't be too many oscilloscope question. You have to do is just go back to the basic of what Mr. Ty's lecture. Okay, so Mr. Ty's lecture back here when you're talking about basic Ohm's law, or you're talking about going to Ohm's law. So you look at this done. So when you go to the AC signal, so right here, go to watch this one right here, number 11 on Mr. Ty's video. How to do AC measurement, and then I'll go through and teach you about the oscilloscope and all that.
Okay.
So any one of these things, anything that covers about the AC signal, yeah, you can go watch the oscilloscope. And then the more you watch it, the more that, and then just getting familiar with it. There's going to be not too many questions. Like I said, you only have like one question on here. We're talking about, yeah, you only have one question right here, and then you got how to do the phase angles and all that. And you can, once you get into the lab, once you get to practice this, and then it's going to become to you easily. It's not going to be too difficult. Once you have your hands-on training of using oscilloscope, you're going to get a hang of it really quick. Okay.
Okay, thank you.
You're welcome. Yeah, just kind of go, make sure you go back and do just this review question several times. You know, like I said, most of them is going to be similar to this. Now we're going to put maybe a few surprise question on there, maybe 2 or 3. So, and that usually about something about the decibel. So just kind of look into the decibel a little bit, okay? But everything else, pretty much straightforward. Just study now. Okay. So do you have any, so back to you, Mr. Pham, do you have any thing to share?
Thank you, Sam.
You're welcome.
So basically, you can see the review of the test, just a very, very basic for the AC circuitry. So if you saw the question, you know right away how to do what to do, then you'll be okay. Okay, and the final will be very close to the review. Okay, so only thing I can say, just good luck to all of you. Okay.
Thank you, Mr.
Okay.
Pham.
Yeah, we'll be stopped now.
Thank you.
You want it, you can watch video.
Mr. Pham, how many questions is in the final?
50.
50? Okay, thank you.
Okay, good night.
Good night.
Bye, everyone.